Alright students, so hopefully you have printed out this sheet and you are simply checking your work rather than needing me to show you how to do the problems at this point. So I'm going to go through these. If after this set you are still really struggling with this concept or concepts, you're going to need to seek out some extra help. So let me know if you need that. Alright, so what digits are used in base 5? So that's 0, 1, 2, 3, and 4. So we don't go higher than 4 in base 5, because if we have 5 of something, that's our exchange rate. Digits in base 12 are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm writing a T, and 11, and I'm writing an E. Alright, draw a representation of 4, 5, 3 using base pieces. So that's 4 flats, 5 longs, and 3 babies. So on the last screencast on that note sheet, we got to the point where we weren't really thinking about base pieces quite as much when we were converting back and forth. So I just wanted to come back around to that again. So these are my base pieces that I would use to represent 4, 5, 3 in base 6. And what I want to think about here is if I were to take each of these base pieces and break them up until they were in their smallest form, which is babies, how many babies would I have, right? So what that requires me to do is say, hey, each one of these flats, when I'm in base 6, has 36 babies, and each one of these longs is 6 babies, and of course my ones are ones. So 36 times 4 plus 5 times 6 plus 3, and let's see if I can do this without a calculator. 144 plus 30 plus 3 is going to be 177. Okay, so the next one, I'm going the other direction. So I have this big pile of babies, and I need to take them and form base pieces that are in base 8. So I want to draw the base pieces that I would get. So my base pieces, I need to make sure I know what's what. My babies will be 1s, my longs will be 8s, my flats are 64, my shadows are 512, and that's going to be all I need, because if I go higher than that, I'm going to way surpass 672. So I know I'm going to need one of my shadows. And when I do that one shadow, it means I've used up 512 of the babies out of the pile, and I've got 160 left to work with. So now I want to know how many flats that's going to get me. So if I take 160 and I think about how many 64s I can form out of that, that's going to be 2. So now I'm going to subtract 128. And 160 minus 128 is 32. So next I go back and I'm looking at my 8s. How many groups of 8 can I get? And I can get 4 exactly. And that is going to be subtracting 32, and I have 0 babies. So this is my correct base representation. Alright, next up is another one of these problems where I've written a number incorrectly based on the base that it's in. So I want to be writing in base 6, so 8s and 7s are out. So I'm going to draw a representation. And that's based on what exactly it's showing me. Right? And then I'm going to think about the fact that I'm in base 6, and I'm going to make exchanges based on that. So I'm going to take these 6 ones, and I'm going to turn it into a long. And I'm going to take 6 longs, and I'm going to turn that into a flat. So my correct representation is 2 flats, 3 longs, and 1 1 in base 6. Alright, the next problem is essentially I'm counting in a base, and so I have to make sure that I keep kind of rolling over to the next place value. So I'm filling in the blanks, I'm finding the pattern here, and I have to make sure I know what I'm counting by. And it looks like I'm going up by 1s, from 133 to 134, 143 to 144, that's telling me I am. So I am going to write what comes after 131, and that is 132, 133, 134. Now the next number, and I'll write this and then I'm going to cross it out, would be 135. But that's not correct because I'm in base 5, I can't have a 5. So instead this group of 5 comes over here and is counted in the 5s column. So it's 140. Write this to help you out, but this is the correct answer. I'm not writing the 5s on here. Then I go 141, 142, sigh of relief because 143 is right. And then I've got 144, and then again, I'm going to write it incorrectly, 145. I think, well, wait a minute, that's not right. This 5 needs to come over here, but then that would become a 5, which is not okay. So then these 5 need to come over here. So I have 2, 0, 0. And then in this last blank down here, I'm just going to move it up here so it looks a little better. Ignore that. It's going to be 2, 0, 1. Okay, so this next one, I am in base 8, and I am not going up by 1s this time. So from 2, 2 to 2, 5, that's an increase of 3. And from 2, 5 to 3, 0, that's an increase of 3 also. So if I take my 5 1s that I have here and I add 3 more 1s on, that's another group of 8. So it turns into 3, 0, base 8. So that goes up by 3 to 3, 3. So I need to keep following that pattern. So I'll just write that in because I think that'll help us to go along. Alright, so from 3, 3, 3 more than that is 3, 6, and that's all good. Alright, now if I were to do the next one, that would be 3, 9, but that's not okay. I can't have 9 1s in base 8, so I would take 8 of them and move them over here to become a 4, and I'd still have a 1 straggler here left behind. Alright, so from 4, 1, add 3 onto that, that becomes 4, 4. Add 3 onto that, 4, 7. Yeah, I'm okay with that. I add 3 more onto here, and I'm going to think of this a little bit differently this time. So when I add 1 on, that gives me an 8, which pops this over to a 5. Okay, but I need to add 2 more on. So the 1 turned this into an 8, which moved over to this column and gave me, you can think of it as 5, 0, and then I had 2 more 1s. So my last number here is 5, 2. Alright, I'm going to skip down here and do this one before number 9 because it's a little bit faster. And I want the largest 6-digit base 2 number. So that is, the largest digit I can use in base 2 is a 1. So the largest number I can write in base 2 that is 6-digit long is 1, 1, 1, 1, 1, 1. In base 2. Alright, so now I'm kind of trying to fuse 2 different concepts together with this question. So I've got numbers in different bases, and I've got these THs at the end. So this is like talking about first, second, third, fourth, or what have you. And the meaning, okay, of these numbers is ordinal. So that's just a review of when I'm talking about the order, where I'm at that place in a line, that's an ordinal use. So I need to know who's going to get to buy the tickets first. So I need to take Ricardo's place in line, which is 1, 2, 1, and he's in base 6. And I'm going to convert that to base 10. So I'm going to say times 1, and base 6 again, times 6, times 36. So 36 plus 6 plus 1 is 43. So Ricardo's 43rd in line. Now let's take a look at Jasmine. Jasmine is 103, but she's in base 7. So I'm going to multiply by these correct values for my places that I'm in. So this is going to be 49 plus 0, because I don't have any 7s, plus 3 So Jasmine is 52nd in line. So if I want to know who is going to buy their tickets first, Ricardo is ahead. And that's it. Hope you guys are doing well with these concepts.